Hi everyone. Today we're going to continue talking about the periodic table. So the periodic table, as we discussed yesterday, is a chart that shows all of the elements. There's 118 in total. We can get a lot of information off of the periodic table. When we look at each element, each one of these simplest substances, we can find a symbol for them, which is usually one or two letter abbreviation. First letter is always capitalized. And we can also get a unique number for them, which is called our atomic number. Now, while that is a lot of information, there's even more that we can learn about each element depending on where it is on the periodic table. So let's look at that. First off, I want to point out that not everything on the periodic table is what we would call a natural element. Okay, so we have essentially three kinds of elements. We have these in the gray, which are naturally occurring on Earth, which means these are things that we would find on Earth naturally. They would be in Earth's crust, in Earth's core. Um, they don't need to be man-made, in other words. Now, we also have these few green elements. So these ones that are highlighted in green, these are ones that are not really found on Earth, and they're extremely rare in the entire universe. And so we don't normally count those as naturally occurring elements like we do those ones that are shaded gray. And then finally, we have what we call purely synthetic elements. So these purely synthetic elements are the ones that are shown here. They're shaded in pink. And purely synthetic elements have only been created by humans uh, inside of laboratories. Generally speaking, these synthetic elements are created in a very expensive and very controlled laboratory setting, and most of the time the elements last for maybe even a second. So they are not very stable. In other words, they don't last very long. They disintegrate into something else. So for me, I have trouble actually even counting these synthetic elements as elements when I'm thinking about them. But we do have both natural and synthetic elements. So keep that in mind, please. All right. When we talk about the elements, there's one property that we need to keep in the back of our mind, and that's something called reactivity. Remember, the elements are simply ingredients, they're building blocks to build other things. So when we talk about the chemical property of reactivity, there's really two sides to that coin, and I want you to think of those two sides as being, is the element reactive or is it stable? So when we say an element is reactive, that really just means that it combines easily with other elements to make new substances. So in the picture here, this is actually showing what happens when we place the element sodium just in water. So we can see that we get a huge fireball. The glass container that this was placed into, you can see has burst. So this releases a lot of energy. Sodium is extremely reactive. Now, on the other hand, or sort of the opposite of that, is we also have elements that are stable. These are elements that do not combine easily with other elements. They are very happy to remain unchanged. And so when we look at some of the gases, we sometimes call them noble gases or stable gases that are to the very far right side of the periodic table. Things like neon and argon, those are going to be proved to be very, very stable. Let's continue to look at that. So to begin with, let's look and see how the periodic table is organized. So here we have these different periods. So it is called the periodic table for a reason, and here's why. So I want you to notice that we have these horizontal rows. When we looked at atomic number yesterday, if I want to encourage you to remember that we were able to look at atomic number by counting from left to right and looking at the number on each row. Okay, so a period is simply a row on the periodic table. So here is row 1 in the red, and we can see there's some space in there. Here's row 2, which is in the orange. Row 3 is yellow. Row 4 is green. But you get the idea. These periods run side to side. So when we look on each period, when we look at these elements that are over to the very far left side, these are going to be extremely reactive elements. So we would find sodium in here. So sodium is one of the elements that would be over here. And if we were to look to the very far right side, we would find those noble gases that I was talking about. So as we move further to the left, we have more reactive elements. As we move further to the right side, on these rows, then we get the more stable elements. So periods, those are the horizontal rows on the periodic table. We can also look at the columns that go up and down. So we call these families. So I've also seen these called groups. So remember, the up and down columns, these are called families, sometimes called groups. Now, if we look at the elements within each family, those elements are going to have very similar properties. So in other words, all of the elements here in this column, the red column, are going to behave similarly and they're going to look the same. If we were to go over to the blue, every element in this family is going to behave similarly and it's going to look similar because they're in the same family, very much the same way that maybe you look like some of the people and behave like some of the people in your family. So when we talk about the periodic table, we also have to talk about metals and nonmetals. And so let me first define what I mean by metal and nonmetal. Now, metals are things that you're already familiar with. Metals are substances that are shiny, they are bendable, so they can be bent without breaking, and often they're good conductors. And when I say conductor, hopefully you remember this from something you've learned before. Conductor is just any substance that allows heat and electricity to pass through it very easily. So these three qualities very well describe what metals are. Nonmetals, on the other hand, as it would indicate actually in the word itself, are things that don't behave like metals. So nonmetals are substances that are dull, which means they don't reflect light. They're not very shiny. They're brittle, which means they break apart very easily. They don't bend. They're good insulators instead of conductors. And so an insulator is any substance that does not allow heat or electricity to pass very easily. So let's look and see how nonmetals and metals play out on the actual periodic table. So if we were to look at metals versus nonmetals, the overall preponderance, most of the elements on the periodic table turn out to be elements. Everything that's shown here in red are actually metals. So 75% of all of these unique substances, 3 out of every 4 are going to be metals. Okay? Now, we also have here, we have these elements that are shown in the blue. Please notice hydrogen is part of that. Please notice that we have all of these that are listed as nonmetals. Okay? So these substances that are shaded in blue are going to they're going to be dull, they're going to be brittle, and they're going to be poor conductors. In other words, insulators. Okay? All right, so we can see that mostly we have metals. I do want to take a moment and point out that we have these really about 6 elements here that are neither shaded red, which we would see for the metals, or blue for the nonmetals. We call these metalloids. So metalloids are substances that have both properties of metals and properties of nonmetals. They're sort of this transition between a metal and between a nonmetal. And it turns out we can do some really neat things with these. All right, guys, I want to stop there for today. And so we'll talk a little bit more about the periodic table, and then we're going to move on to talking about something called atoms. Hope you have a great day.